Twitter metadata is structured. We know that if someone retweets something, that is quite straightforward, but how do we know about research areas and organizations of unknown projects? This is quite a different thing. Because if you think about the Chimpanzee project, how can you see if that is a biodiversity project or not? And the key is that we move from unstructured text to structured data. So let's get back to the chimpanzee example, because this is the project description. And I would say that this is the goldmine of our CS track research that is based on text analytics, because we can find a lot there. And of course, it's not that easy at the first sight. But if we read that carefully, we can see, for example, what or which research areas are covered by this text. We can see which organizations occur. We can read some dates and milestones for the project, names and persons of, for example, important coordinators, for example, or researchers, and so on. But if you think about the data, what is the difference between research area and organization? What is easier to identify? And the answer is organizations, for example, are usually just a word that occurs explicitly in the text. But if you have a research area, that is not the case. What is actually a research area about, and how can we identify the predominant research area in CS? So how can we observe research areas in text, and what are the topics and concepts of a text? Very quick thing, seal versus seal. You probably know that both of those pictures are seals. There are, of course, other connotations as well. But let's take a look. We have now a text snippet, and the question is it now about the animal seal or the item seal? So if you read that, the average lifespan varies with different species and so on. I think it's quite easy for you to distinguish those two terms and say which that is. And the other is the less noble classes began wearing, and so on and so on. And I guess it's quite easy for you to say that the upper one is the animal seal and the lower one is the item. But why is that the case? So the topic of a text corresponds to the words used and the concepts described in the specific context. That is straightforward, but if you think about those very complex AI methods about deep learning and so on, you cannot relate to those simple things. But if you have real text analytics methods, you can interpret that and think about those connotations. So let's go back to this snippet. There you have specific terms like lifespan, species, females, populations, hunting, environmental threats. Those are words that say or that indicate for you that this is about the animal, because there's a specific context. So there might be some background knowledge that qualifies you to make that decision. Where do you have that context from? And the answer is encyclopedias like Wikipedia, for example. They span the background knowledge that you might need. So if you think about research areas, there are specific concepts that you could find in those encyclopedias. For example, biodiversity, there's an article about that. And now the question is, can we map all those research areas to Wikipedia articles? The answer is yes, it's quite easy, but we need to know how. There are, for example, taxonomies like Web of Science that already have a category schema. So there are people who think about metadata and schemes, like Brandon, for example. Brandon is thinking about PSR core metadata. There are other people thinking about metadata for classifying research areas, for example, for publications. And in the Web of Science taxonomy, there are a lot of research areas divided into categories. And the interesting thing is, you could find for all of them a Wikipedia article that describes that. So what we actually did, we took all those Web of Science categories, topics, and found a Wikipedia article. That is easy. But how can we now relate text to that? Because what we have implicitly in our minds, how can we let an algorithm know that? And the answer is quite easy. We compare that. So we just compare the project descriptions that we have to the Wikipedia articles. We have a similarity measure. And then we can say that this project description of, for example, chimpanzee contains the research area biodiversity, but also environmental sciences. And the algorithm that we use, or method, that is called explicit semantic analysis. And now we have those mandatory, very complicated slides that we have in every scientific presentation. And this is how everything works. So if you want to know more, there's a reference about that. And of course, if you search for explicit semantic analysis, you find a lot about that. It's a straightforward method that can be easily interpreted. You always rely on a background knowledge that is based on, let's say, an encyclopedia like Wikipedia. And then you have vectors that represent the concepts that are in this encyclopedia. For example, the research areas itself. And then you create some kind of lookup table that you use for the computation. So a matrix that consists of all the words that are contained in all the articles or concepts. And then you can calculate a semantic similarity based on the cosine similarity measure between the new project description vector and the old research area vectors. So basically, it's just simple mathematics that you apply based on vector geometry that facilitates a simple similarity measure. And of course, that is also in the library that we provide you. So if you go to the CS-Track GitHub repository, you can just use that without re-implementing that. So what we have, then we just analyzed all the Zooniverse projects that we have found in the database, and we could see that most of them are multidisciplinary. So there is, of course, a predominant research area, but many projects are covering multiple research areas. And in the common research that we found, this was not always the case. So the next part is which organizations are connecting those projects. So yeah, Brendan?
So you have a lot of content to cover, so I don't want to take you too far off to the side.
No problem.
Here. Because this research area, in PPSR core, it maps very cleanly to scientific field or scientific area. I forget the exact term that we're using in the standard. But right now, that field is somewhat of a mess because it is a conglomeration of different standards from across the globe, because Australia, the Australian Citizen Science Association, follows the Australian government's classification of scientific field. In the United States, it's kind of fragmented by different universities. And in the EU, it's not very centralized either. So what we have is kind of a best attempt at trying to combine those existing standards, recognizing the fact that there wasn't a global standard. One of the things that we would like to do, further in the future is, rely on, other, sources. And I think for this specific field, scientific area and research area, there's some benefits for using this type of research to develop that list, recognizing the fact that for many of the implementations of this, it'd be projects self-selecting their research area rather than a textual analysis. But this could, I think that this could form a very good foundational part for that part of the standard. If you'd be interested in presenting that.
Yeah, would be great. We also thought about that because we consolidated also this PPSR core things. You have seen the work that has been done with the database in the last workshop session. This was quite challenging because, as you said, that there was a lot of mess how the projects used that, and I think automating that is, of course, one of the steps. Of course, it would be better if people pre-select that accordingly, but they are not doing that. So we have to extract data and we have to extract the research areas. I think maybe consolidating also this Web of Science scheme would be also a good thing because I think, at least in my understanding and what I've read so far, this is quite balanced, the schema. There are some other schemas for research areas that are not that well designed. For example, field of science we have seen that there are a lot of fallbacks, for example, which make it very complicated to be used with computational content analysis, and I think that might be a good schema. I don't know which you have used exactly.
I haven't used either of those schemas. It's been government based and kind of derivatives of. So no, this is great work. Is this schema actually separate, or is this schema actually more defined within Wikipedia and they're just adopting it?
Well, it's from the Web of Science, from Clarivate, which serves probably one of the biggest literature databases in the world. So I would say that this is the most accepted schema for classifying research areas.
Okay.
And this is not really our work. We just did this mapping from Wikipedia articles to those categories.
Okay. Because Wikipedia does have quite a bit of that metadata built in, and there are a lot of Wikipedia aggregators that are themselves doing this type of analysis.
Yeah.
Okay. But it was more mapping from one to the other.
Yeah.